Create joints. In this video, we'll create a revolute joint and we'll create a motion link. In Fusion 360, we want to carry on with our gear reduction housing assembly. We've created as-built revolute joints for all the gears in our gear train. But what would happen if one of the gears was not in the correct position? If we hadn't used a line and we wanted to still create a joint? Well, we can go to the last as-built revolute joint we created, and I'm going to select Delete on the keyboard to get rid of that capture position and to get rid of that revolute joint. Then I want to move this gear out of position and capture it. So if your gear was brought in and it was not in the correct position, you can still create a joint by going to Assemble and selecting Joint. Remember, as-built joint makes use of the current position of the component. A joint will allow you to select the points on multiple components that you want to align. This can be done a few different ways. Simple will allow us to select a reference point. Between two faces will allow us to select two faces and it'll automatically go to the middle, or we can select two edge intersection. The first thing that I'm going to do is first set my type to revolute. And then for the position, I'm going to start by rotating my gear around. And similar to how we used a line, I'm going to hold down the Control or Command key and select that center point, noting the orientation of X, Y, and Z, Z being our blue axis. Next, I need to select where this is going to go. Once again, holding down Control or Command, I'll go to the center point of this opening, noting the direction of the Z coordinate system. Once it's in position, note that it's automatically set to 0 degrees, and the offset values here are all set to 0. Even though we manually selected those positions, we could still offset them or rotate them if we wanted to. You'll notice that there is a slight amount of overlap here, so we can use the on-screen manipulator to rotate their position, noting that we want to go to about -3 degrees. And you'll notice that we're getting more overlap. So if we go to a +3 degrees, we're starting to go the other way. All of our other gears were about 20 degrees off, and it looks like this one is still a bit more off than that. When we get to 30 degrees, we're much closer. So I'm going to insert a value of 32 degrees to see if that gets us close enough. It's going the wrong way, so we can go backwards to 28 degrees. If we're having difficulty at this step, we can say OK, and we can manually rotate this around and capture its position as well. Now that we have that new joint added, we want to add motion links between our different joints. To do that, we'll go to Assemble and we'll select something called a motion link. The main motion link that we want is between our 16-tooth and 48-tooth, but we're going to work our way through the gear train system, starting with this joint and moving to our first idler. What we want to do is we want to remember that we're going based on a ratio of the gear. So we're having a 16-degree or 16-tooth rotation and a 10-tooth rotation in the opposite direction. Noting that that is just way too much rotation, so let's flip those numbers around, going 10 and 16. If we do that, you can see that the relationship is much better. We'll repeat that motion link, this time going between these two gears, reversing the direction, noting that they're both 10-tooth, so they're going to be the same. We'll do that one more time between the two idlers. You note that those are both 10-tooth, so those are the same. And lastly, we'll repeat it one more time, going between this idler and the large gear. Now this is going to be 10-tooth in and 48-tooth out. But again, we might need to reverse those 48 and 10 and reverse their direction. So now if we rotate that large gear, you should see that everything is moving as intended. For this, let's go back to a home position and save the design before we move on to the next step.